So this is our last topic in chapter 12. We've graphed circles, we've graphed ellipses, we've worked with parabolas, and finally we're going to look at something called a hyperbola, which you've actually seen in rational expressions. Those were those two branched, like one was up, one was down type thing. You've seen that before, but now we're actually going to work with equations that look a little bit more different and how to deal with them. So first, what is a hyperbola? It is the set of all points in a plane such that the difference, the key word here, of their distances from, again, two fixed points is constant. And we call these, in this case, these fixed points are called foci, or focuses, but the plural of focus is foci, or foci, sometimes you might hear. Alright, so first, again, like we did with ellipses, we're going to talk about centered and origin, and then we're going to talk about centered at HK. Hyperbolas are a little bit unique in that we have left and right opening ones, and we have up and down opening ones. Left and right is when x is first in the equation. So when x appears first in the equation, we know that it's going to be left and right. So first, again, we're going to talk about centered at origin. Looks like x squared over a squared minus, so instead of being plus like the ellipse was, we're subtracting b squared equals 1. So we're going to talk about some steps. We're going to go through an example and then talk about centered at HK. Alright, so number 1, we're going to locate the x-intercepts. So locate x-intercepts, and those are at a0 and at negative a0. So basically solving for a. Step 2 is to draw the fundamental rectangle, and we'll talk about what that is when we go to the example. And that's using plus and minus a and plus or minus b. Alright, our next step is going to be to draw the extended diagonals. Draw extended diagonals of the rectangle to create asymptotes. And then finally, we draw in the hyperbola using asymptotes as guide. So to approach them, basically. Alright, so a lot of that doesn't make sense without doing an example. So let's talk about it. So locating the x-intercepts. Number 1, a0, so we need to set a squared equals 36. Square root, so a equals plus or minus 6. So my asymptotes, or not my asymptotes, my x-intercepts are at negative 6, 0 and 6, 0. So I gotta go over to 6, 0, down here, plot, and negative 6, 0, and plot. Now, I need to figure out what b was. So b, again, that's 9, so b squared equals 9, b equals plus or minus 3. So from these 2 points, those are your foci, or foci. you're going to go up 3. 1, 2, 3. Plot kind of a small point. You don't really want to, it's not actually a point on the grid. So then go down 3, and then same thing with the other point over there. Up 3, down 3. And here's where you make your fundamental triangle. Connect your points straight down, straight across, straight down, and straight across. Now the extended diagonals is connecting point A over here to point B and extending them. So I'm going to kind of move my paper so that I can get it. Right. And again, asymptotes are always dotted, so got to make sure we dot here. Asymptote number 1 and asymptote number 2. Now lastly, we need to use those points. So remember we started here and follow the asymptote. So follow the asymptote that way, curve and follow it out this way. Same thing, got my foci over here, follow it out. It's not going to go past the focus. So then I've got a hyperbola. They open opposite directions, started with x, so they open left and open right. Alright? So let's go back and talk about HK. Just like an ellipse, the equation is very similar. X minus h squared over a squared minus y minus k squared and over b squared equals 1. The only thing that's different is step 1 now becomes find your center. So finding the center, go ahead, find that. In this case, it is, let's see, oh, we didn't have an example yet. Then you're going to use step 2, use plus or minus A, plus or minus B to create the rectangle. And then draw your diagonals, and again, kind of keep going from there. We'll get our focus by using plus or minus A. So focus points, we'll find that. Alright, so center first. We've got center at 3, negative 1. So center, go ahead, 3, go down 1. Again, that's not actually a point, but that's where the center is. Since x leads, we need plus or minus a first. A squared equals 16, so a equals plus or minus 4. This is how we'll get our foci. 1, 2, 3, 4 from the center. 1, 2, 3, 4 from the center. So focus, or foci, are going to be 7, negative 1, and negative 1, negative 1. Alright, now we make our fundamental rectangle, sorry. B squared equals 4, B equals plus or minus 2. So from the focus, go up 2, 1, 2, down 2, same thing over here, up 2, down 2. Oop, I didn't go up 2 on that one. There we go. Alright, connect it, make the rectangle. And now I need to put my extended diagonals in. So extended diagonals. And lastly, I need to connect the points back together, following towards the asymptotes. Start at the focus, towards the asymptote, focus towards the asymptote, focus out towards the asymptote, and focus out towards. Again, we have two parabolas opening left and right, called a hyperbola. So that's left and right. The only thing that changes here is yours. Actually, we're going to talk about opening up and down. So up and down. So the only thing that changes here is y is first in your equation. So we have y squared over b squared minus, again, x squared over a squared equals 1. Its counterpart, y minus k squared over b squared minus x minus h squared over a squared equals 1. So our strategy for graphing, if it's at the center, instead we're going to find the y-intercept first. So that's when when the center is the origin. So this is when it's origin. At HK, you find center first. And you need to be careful, remember, so star, careful with HK. What I mean by that is because K comes first, then H, so you got to be careful there. Then all the steps that follow are drawing, again, the fundamental rectangle. And then drawing your extended diagonals. Which are really your asymptotes. And then draw hyperbola by following your asymptotes. So again, you find your center first. You're going to use plus or minus b to find the focus. So use plus or minus b to plot your foci. And then you're going to create the fundamental triangle, or rectangle. And then you follow the steps over there. Alright, so let's figure out where we're centered. Go ahead and all that. So y is first. Let's find our center. So nothing with y. There's opposite x. So -1, that's h first. And then k inside the y. Well, that's 0. So -1, 0. We need to find b first. So use plus or minus b. B squared equals 3. Oh, I'm thinking ahead. B squared equals 9. So b equals plus or minus 3. So plot the focus. 1, 2, 3. That's an actual point. And down 3. Actual point. So that's -1, 3. And -1, -3. So those are your foci. Create the fundamental rectangle, so we need a squared equals 4. A equals plus or minus 2. So go plus or minus 2 from your focus. 1, 2, 1, 2, over 2, over 2. Connect them to make the rectangle. And we need to draw in the extended diagonals. And finally, draw your hyperbola using those focus points and your knowledge of it opening up, following where they are. So we got opening up and opening down. Again, y was first, so we know that they should open up and down. Alright, so that's everything you need to know about graphing a hyperbola. You should try these two now. Be careful of which one is first. That is my advice to you. Alright? bring it to class tomorrow.